Why does this little spinning thing help an aircraft stay stable in rough air? And why does it move in a direction that feels sideways? Because a spinning rotor stores angular momentum. When you push on it, it doesn't react where you push, it reacts 90 degrees later. That sideways reaction is called precession, and aircraft use it as a rock-solid reference for which way is up and which way are we turning. A spinning rotor wants to keep pointing the same way. That's not magic, it's angular momentum. The faster it spins, and the more mass it has out at the rim, the more stubborn it becomes. Watch a spinning top. Gravity is pulling it down, yet it doesn't just flop over. It slowly turns around. That turning is precession. A torque tries to tip the spin axis, and the gyro responds by rotating around a different axis. Here's the simplest way to feel it. Push on one side of a spinning wheel. Because the wheel is rotating, the push gets carried around. The part you pushed moves away, and a quarter turn later another part is now the one taking that push. So the effect shows up 90 degrees later, sideways. If you want one sentence of physics, torque doesn't kill the spin, it changes the direction of angular momentum. And the rate of precession is basically how hard you twist divided by how much spin you've got. In older aircraft, the attitude indicator contains a fast-spinning gyro on gimbals. The airplane can pitch and roll, but the gyro tends to hold its orientation. The instrument measures the airplane moving around the gyro, giving the pilot an artificial horizon even when the real horizon disappears. Gyros aren't perfect. Friction and tiny torques cause drift. That's why heading indicators need periodic alignment with the magnetic compass. The gyro is stable, but not eternal. Now the fun part, aircraft also use precession on purpose. A rate gyro is built so that when the airplane yaws, the gyro experiences a torque, and it precesses. That precession is proportional to turn rate, so the gyro becomes a turning sensor. Stabilization isn't the gyro holding the airplane. The gyro measures motion and attitude, and the control system uses that signal to correct the airplane. Gyros are the reliable reference that makes autopilot and stability augmentation possible. Modern aircraft often use gyros with no heavy spinning wheel, like ring laser gyros or tiny MEMS sensors. Different technology, same mission, sense rotation precisely, feed the flight computers, and keep the aircraft pointed where you want. So precession isn't a weird trick, it's the predictable way spinning momentum responds to torque. And that predictability becomes sense, then control, then stability. Next question, what else in aviation looks like magic, until you see the physics?